Yeah, my name is Ilya, and I'm a senior dev in Atlassian, and as a part of one of my roles in Atlassian, I've been involved in development of cross-product Atlassian server app, which runs in Jira, Confluence, Bitbucket, Server, Bamboo, Ficru, and even Crowd. Um, Also, it provides some data center-specific features and features that require specific database type to be present, for example. And I know how painful it may be just to test your app against the real product environment. And today I'd like to share some of the tricks that I've come into eventually to make the developer's life easier. So today I'm going to talk a little bit about testing in general, a bit about the Atlassian SDK, and but my primary focus of my presentation is going to be Docker and the ways how we can adopt it for your integration test environment and environment. I will be showing some scripting, some examples, but you don't need to write down anything. Like, I will share the links where we'll be able to find all these examples by checking out the repository. So, as probably most of you know, there is a good concept describing types of tests that you like to see in your project, which is called test pyramid, and it's based on the unit tests, which means basically that the most of your tests in your project should be unit tests because they are easier to maintain. And the fewer UI tests you have, the better your testing ecosystem is. And the manual testing should not exist at all, ideally. Unfortunately, it doesn't always work in the real world, and there are some cases that you need to run the real product instance anyway. But when it comes to the effort is proportional. Oops, sorry. Come on. So the effort is proportional to the amount of different types of tests you have in your system. And the main problem with the complicated testing environments is that they're really non-trivial to automate and non-trivial to set up locally. So what do I mean by the complicated environments? For example, data center. Data center is definitely not trivial to automate, to run it locally. And that's why. That's the typical data center environment. Like, we have multiple nodes, we have a shared database. It has to be dedicated database because that's essential for a data center. And also it should have like the shared home folder, it should have the load balancer distributing the requests between the nodes. And to be able to test your app against this environment, you will need to install it into each node, and then you will be able to run integration tests. Another example is a multi-product environment where you run multiple products at once. For example, we have Jira and Confluence, and they both use their own dedicated databases. For example, Jira is using Postgres database, and Confluence is using MySQL database. And also, we probably would like to have those instances to be, like those products to be uplinked to each other, which basically means that we have an additional step of setting up the uplinks. And then we will need to install our app into each of these products, and then we'll be able to run integration tests against this environment. So let's briefly take a look at the minimum set of actions you need to run to just set up the Jira data center. So basically, we need to start database. We need to configure the property files. We need to start the node itself. We need to set up the node as a data center. We need to configure the second node file, and we need to start the second node. And then we will install our app into the running product instance, and only by that moment we will be able to run integration tests. And please bear in mind that every action from this list, it takes time and it's some effort from you. So it basically means that, like, you will spend quite a lot of time just to set this environment up. And if you do this quite regularly, like to test features of your app, then probably like you will become insane at a certain point. And for Jira plus Confluence, that's a similar thing. Basically, we will need to start Jira, start Postgres database, we need to start Confluence, start MySQL, go through the setup process in both of them. What's happening? I didn't press it. Sorry. Okay. Okay, so yeah, basically you would need to set up both products, and then you would need to set up the app links and install your app into both products, and then you will be able to run integration tests. So let's take a look at the ways how we can the Atlassian server products in general for testing and development purposes. There's a well-known and officially recommended way, which is called Atlassian SDK. Basically, it allows us to start the product either from the console by running, for example, Atlas run standalone, indicating the product you'd like to start and the version of it, or you can bundle it into your Maven build by defining this Maven plugin or build configuration in your POM, and then the product will be started along with your integration tests, and that's what we want, right? But the big limitation of such approach is that it doesn't allow us to start multiple products at once. It doesn't allow us to start the dedicated. All it allows us to do is to start the product with the embedded database, which doesn't allow us to test the data center. So I asked this question yesterday, but probably, can you please raise your hand if you have ever started Atlassian server products in years? Nice. Okay, so as most of you know, Docker is like a generic way of starting up repeatable environments. And basically, it's a generic way of starting up anything rather than something Atlassian specific. But of course, you can use it for starting the Atlassian server products as well. So to start anything in Docker, you basically run docker run, then what you would like to start and version. So in case of Confluence server, for example, you would just run Atlassian Confluence server and indicate the version you'd like to start, and also pass the port number you want it to be bind on. And that's pretty easy, right? Another thing is Docker Compose. It's the tool which comes along with Docker. And what it allows us to do is to define multiple containers in a single Docker Compose YAML file. And once we want these containers to be started, we just execute Docker Compose up, and it brings this whole environment to life. In the example, like we have two containers. We have database, which is MySQL, and we have Confluence. Yeah, once we run this Docker Compose up, both containers will be started. Sure. Hello, hello. 1, 2, 3. Yeah, I think we can try. Yeah. Testing, testing. Yeah, looks like I'm really cursed. Um, all right, so speaking about the ways, the running of Atlassian server products in Docker, I should mention that there are officially supported by Atlassian. These are listed on the slide. And in case of Bitbucket server, this is one of the official ways of starting a Bitbucket server in general, even for production. In case of Confluence, it's one of the ways you can use for testing and development purposes. Also, you can find plenty of unofficial Docker images across the internet, but these ones that are listed on the slide, they follow the same conventions as the official ones. So once you adopt the official ones for your integration testing infrastructure, these ones will be really easy to adopt. They're created by the same Premier support engineers of Atlassian. So let's take a look how we would start Jira plus PostgreSQL in Docker Compose. Please note the highlighted text in here. It's very important because we define the volumes for a Jira container, and the volume is dbconfig.xml, which basically allows Jira to connect to the database straight away once it's started. And also we define the persistent volume for the Postgres container, which allows Postgres to store the data. And if you want the data to be persisted across the stops and across the restarts, then it's essential. So once again, we have Jira with some XML configuration. We have Postgres with persistent volume mounted into it. But what happens when Jira starts connecting to the database? Basically, it will start connecting to the database straight away because it has this database connection configuration. Of course, it failed to start because database is empty. We've just created this environment, right? So this leads us to the necessity of having some sort of database backup, which will be restored into the database upon the startup. Unfortunately, Postgres container doesn't support the restoring of database backups out of the box. So we need to in some way tell Postgres to restore this database backup upon the startup. And another problem here is that we need to tell Jira to connect to the Postgres only when Postgres is fully ready to be used. And basically the idea how we can do this is we can introduce a new container which will control the startup process. So basically it will tell Postgres to restore the database backup, and it will tell Jira to start connecting to the database once it's ready. I'll show you how it should work and later, but basically this idea allows us to use the same approach for a data center case. So we have a scale backup file, we have a controller container which controls everything. And the same approach will work with multi-product environment as well. The main issue here is that controller has to be quite smart, so it has to take all this responsibility of starting up every container, and then controlling the order of the startup process. But that's fine. We control this controller. Now we know the theoretical way of starting up these environments, but we need to bundle this startup into our build process. So we need to run tests along these environments, right? How do we do this? There are ways of starting up Docker containers along with your builds. So there is a Docker Maven plugin, which allows us to start Docker containers along with our Maven build. Basically, we can define all the same things as we saw on the previous slides, like the port number, the image, the version, and the volume definitions, and so on. And we can bind the certain executions to the Maven build lifecycle phases. So, as I said, we can start the container before the integration test, and we can stop it after the integration test finished. And similarly, there is a Docker Compose Maven plugin, which allows us to do the same, but with Docker Compose file. So the next question is, how does this controller container actually work? How will it wait until Postgres is fully ready to be used? How will it tell Jira to start connecting to the database only when database is ready? So there is a common way of waiting until something is ready in Docker world, which is commonly known script, which is called wait for. It works pretty easily, just waits until the container opens the port. And there is another feature of Docker itself, which is called health checks, and basically it works the same way. It just waits until the port is open of a container. But unfortunately, it doesn't work with Atlassian server products, because when Jira opens the port, it doesn't mean that Jira is ready, right? So Jira opens the port, and then it goes through the complicated startup process, and when it's ready, we don't know. So one of the possible improvements of this wait for is the extended version of this script, which I've created for you. Basically, it's in addition to waiting until the port is open, it also waits until the HTTP request to Jira is not redirected to a certain page. So here we're waiting until Jira stops redirecting us to the startup and to the secure setup pages. And once it stops redirecting us, it means that Jira is fully ready. This is as hacky as it looks like. And I don't think it's a good solution. We can do better, right?
So I've created this tiny tool specifically for this presentation, and the idea is pretty simple. It's an open source, you can use it. The idea is pretty simple. Basically, we replace the default command, which is intended to be run in a container, to runker. So runker stands for run in Docker. Basically, runker has two modes. It has the server mode. So we replace the default command, which is intended to be run in the container with runker server, and pass the underlying command that has to be run in the container to the server mode. And then we pass the phrase which has to be present in the output, so we can think of this underlying command as ready to be used. So, like for example, service started successfully. If this phrase is present in the output of that command, we can say that the process is ready. And in the controller container, we can use the client mode of runker, which will just connect to the specific container and will tell the container to start the underlying command and wait until the underlying command is ready. And similarly, we can connect to the container and execute the specific command inside of it. For example, restore the database backup. So in case of Jira plus Postgres, it will work literally this way. Yeah, so basically we will replace the command of Jira with runker server, passing the entry point. That's the default command, which has to be run inside of a container. And we wait until the phrase plugin system started is present in the output. That would mean that Jira started. And the same thing for Postgres. We're waiting until the ready to accept connections is present in the output of Postgres. And in this way, like we can, from the controller container, we can connect to the Postgres first, then wait until it's ready, then restore the database backup, and then connect to Jira, and then tell it to start, because we know that Postgres is ready by that time, right? So the next thing, so once we've done all of that, we know that the product instance is ready. The product instance is running. So another thing is which we need to do is installation of our app into the running product instance. So with Atlassian SDK, it's done pretty simple because it's done for you. It's done using the quick reload or something like that. But in the Docker world, it doesn't work this way. So we have to install this app manually. And fortunately, every Atlassian server product exposes the REST endpoint, the so-called UPM REST endpoint, which allows us to just upload our app directly into the UPM. The only tricky moment here is that we need to request for UPM token first, but this can be scripted quite easily. So we request for the token, and then using this token, we upload the app. And once we've done all of that, we need to wait until the plugin, the app is fully installed into the running product instance, and then we can install when we can run integration test against this environment because it's fully ready. It has our app running and like etc. And this is how we can wait until it's ready. Basically, once the controller container exits, that would mean that everything is ready to be used. And once everything is prepared this way, we basically can execute mvn clean verify, and it will start up everything and run an integration test, and it'll stop afterwards. So this is the example how it may work. This is the output of the example which I've prepared for you. So it's starting the data center environment, restores the database backup, installs the app into the running instance, and then stops the environment, runs the integration test, and then stops the environment. And everything is taking just 3 minutes. Yeah, that's basically all I've got. If you have any questions, please ask.
First of all, thanks for this talk. Might have been one of the more helpful talks here. How do you do the first setup with the database configuration, the license, and the admin setup?
Yeah, that's a good question. So basically, the first setup, you need to prepare that database backup file first, right? You need to do it manually. And my recommendation would be to because like I've been working with the plugin which runs in many different versions of different products, and we had to support like very old Jira versions. So basically, what I did, I prepared the database backup with the old Jira version, and then like saved it into the file system, and then started like if you started with a new Jira version, Jira will run the upgrade and will upgrade the database to the newer version right away. And it takes like not a long time, depending on the size of your database backup, of course.
We have time. I don't think there's another thing until like 10 o'clock. Yeah, got one right there.
Good morning. You said that you, within this scripted environment, you run your integration tests. Can you detail this a little bit more, how you run integration tests in another environment than the Atlas Run SDK?
I'm not sure if I get it correctly.
Yeah, you just said, okay, you start up the environment and then integration tests are run.
Yep.
Can you give a little more detail how you made it to make these integration tests running automated within this setup of environment? Because all the documentation is all about use the Atlassian SDK and start it up, but nothing about running tests in a standalone instance.
Okay. Yeah. So Atlassian SDK is a kind of a broad term. Like it includes the command line client and also the Maven Amps plugin. So Maven Amps plugin does everything for you. It basically binds the certain binds the certain executions to certain Maven lifecycle phases. So it runs integration tests for you. But Maven actually provides all of these features by default. So basically, what you need to do, you need to use the Maven failsafe plugin, which is intended to run the integration tests. It's basically the same thing as the Maven Surefire plugin, which is intended to run unit tests. But the significant difference is that it doesn't fail your build if your integration tests fail. So the post-integration test phase still runs and like destroys everything. But then, like afterwards, it fails the build. So without, basically, the example that I've prepared, it also includes the Maven Amps plugin, but it uses it only for building the app. Basically, to build your app, you don't need the Amps plugin in general. The only thing you need to have is a Maven bundle plugin, which is a default OSGI Maven plugin, which allows you to basically build the OSGI bundle. But I'm using Amps because it's a default thing that comes along with the Atlassian SDK. But running the integration tests, you need to make sure that failsafe plugin is running and it's bound to a certain Maven lifecycle phase. And that's basically it. So once you execute this MVN clean verify, it runs all the builds. It builds your app, and then runs the pre-integration phase bindings, and then runs the integration tests, and then runs the post-integration test bindings. That's the default Maven behavior.
Any other questions or any insights that anyone else wants to share of how they do things differently?
I just wanted to share the insight that there are system properties for the Atlassian apps that make them start up synchronously rather than async. So you can use the standard method of waiting for a port to open. But there's being Atlassian, the system properties for each app are different, but you can find them if you search.
Okay.
Going once, twice. Ilya, thank you very much.
Thank you.